have the distinct honor of introducing our next speaker, and I wrote a little bit here. It's a long diatribe, but bear with me. So our next speaker is sort of our international invite. So she's jet lagged right now, but representing a significant North American early IPv6 adopter, which was Microsoft. I consider her a singular force in sort of the IPv6 community, as she was the founder and chair of the UK IPv6 Council. She's an accomplished networking professional. Prior to her current role with Microsoft, where she's leading the Enterprise IPv6-Only effort, she was a consulting system engineer in the global service provider team for Cisco. Some of the key accounts she worked on were adopting and deploying IPv6 with a lot of her guidance. And additionally, Veronika's led many of the Cisco live IPv6 addressing workshops. So if you've had the opportunity to sit through those, she does a fantastic job with them. She has previously been recognized with the Jim Bound Award for contributions to the IPv6 community by the IPv6 Forum. And it's sort of with great pleasure I get to introduce you and have you present Microsoft IT, the journey to IPv6, where you're at and where things are going next and everything else.
Excellent. Thank you very much, Ed. Clicker. Can everybody hear me? The mic works? Thank you. All right, thank you very much, Ed, for the introduction. Good morning, everybody. As Ed said, in case I kind of like suddenly collapse, it's just because I fell asleep. It's not because I've got some medical problem. But hopefully we will get through this just fine. So I've joined the network architecture team in Microsoft about 4 or 5 months ago, and it's a very steep learning curve for me. The team is absolutely fantastic, also very smart and really very experienced engineers and architects, so I'm learning a lot with them, and I'm very honored that I can be involved and help them with our IPv6 journey. So through the next 40 minutes, we will cover a couple of topics. Let me just build a slide. So I'll give you a brief network overview. We'll also talk about the IPv6 Dualstack, where we are and how it started and where we are right now. Why are we actually moving to IPv6 only, and what is the current status of these efforts? Obviously, of course, future directions, because we are at the beginning. However, I also would like to share with you some observations that I have made over the years in the UK IPv6 Council, because prior to working with some large ISPs in the UK, I also worked with some large enterprises, and you can judge from my accent, I'm not native English. I come from Czech Republic, and there I worked with a large national research network who were also pioneers in rolling out V6, and they gave my then employer Cisco quite a lot of grief about lack of V6 feature support. So I've actually seen quite a bit over the years. There are obviously here people in the room who are a lot more experienced than me, so I'm really enjoying this event and learning from you a lot, guys. I would like to share with you some perspective on service provider, IPv6 and enterprise and IPv6, and also why enterprises are not picking up IPv6 as much as we would like. So let's start with Microsoft first and the network. Just to give you an idea what actually is the effort that's needed to roll out IPv6 in such an organization. So we've got 4 regions. That's how we kind of divide the network. One of the regions is the main campus in Redmond, Washington, where there's tens of thousands of employees based. I think it's 100+ buildings that we've got there. I was there only once in January, first time, and I've seen only a few of them, and I know I need to drive between the buildings, and I also can take a shuttle. So it's quite a big campus. Then obviously we've got North America, Europe, Middle East, and Africa. That's another region, and of course Asia Pacific. That in total is about 790 locations. That's kind of changing because we are redeveloping our campuses, expanding them, etc. So there's quite a few locations that need to be considered when we were thinking about rolling out IPv6. We also have on-premise data centers that they've got their own BGPs. There's one thing I probably need to say. What part of network architecture team, what team I'm from actually, that's Microsoft IT. because usually when people hear Microsoft, they immediately think of Azure, okay? So they are our partners. We work with them very closely. But if there are any complaints against Azure and IPv6, I'm happy to take the comments to my colleagues. However, I probably will not be able to answer those questions. Tail sites or branches that are in those regions are connected usually over MPLS network, layer 3 VPNs. We've got internet peering enabled in multiple locations in the regions. Most often we peer with our online services, AS, which is Azure, Microsoft.com, Bing, Office 365, that's what it services. And just the size of the company, full-time employees, we are about 113,000 full-time employees. If you take in all the vendors and contractors, then we are talking over 200,000 users that this network has to support. What it also means, besides users who bring their own devices into and connect them to the network, we also have lots of applications, which is something that we'll have to focus on a lot when we are looking at v6 only on the corporate network, right? So that's about the statistics that I've got from our IT team is 1,900 line of business applications that we manage. It's quite a few. And then, this is another statistics last year. This is a statistics from August last year, which probably could change and grow again. We see about 1.2 million devices hitting the network. That includes obviously the network infrastructure, etc., user devices, everything that leverages the network. So it's quite a big network that we need to support and that need to be moved to v6. So how it all really started, as I mentioned, Microsoft was one of the early adopters, thanks to the research arm of Microsoft, because they were investigating and researching IPv6 since 2001. In order to support these efforts and the various research locations, basically we built for them ISOTAP network, which was first based on the Windows service, but because that, of course, didn't scale, that it was moved to a hardware routing platform. And then, a few years later, 2006 specifically, we started to look at deploying v6 more globally, in using a mixture of ISOTAP and Dualstack in the network. Mostly we were focusing on development centers. That is kind of a natural step. Even when I was in Cisco, I know that we first had to support our developers, because if we are delivering features and functionality for the customers, our engineers need to be able to test it and deploy it and test it and have network that can support it. So first, really, the focus was on these large development locations. In 2011, IPv6 became strategic goal. I think that when I look at it from the historic perspective, it was the year when really the voices of the industry running out of IPv6 addressing space became really loud, right? So everybody can also remember, which was probably one of the first large IPv4 addresses purchases, was when Microsoft bought the Nortel IP4 addressing block, and that's what kind of set the price, right? The $11, the magic number, we were discussing it here yesterday. So that was one of the first ones that actually hit the news. How amazing, IP makes it to the news, the headlines. So that address acquisition was actually intended for Azure, for the online services. That wasn't for our internal network. But I can tell you that we were already feeling the pressure as a business as a whole, that whatever we had in store, that wasn't really enough to support us for the future. Backbone network at the time was migrated to Dualstack, and we moved to ISI single topology. Just basically, we wanted to have pervasive v4 and v6 everywhere in the network. And fine, if a link doesn't come up because on one side the v6 is not configured and v4 is there, that's not a problem. We better go and fix it rather than have some exceptions. Then you could wonder, okay, so Microsoft, what happened? 2011, v6 became a strategic goal. We can just say that the priorities have shifted. There were other things that we needed to fix in the network to support our users so they could do their daily job, rather than really working more actively on the IPv6 rollout. So since that magic day 2011, all the v4 public addressing spaces moved to Azure, because that's the area where Microsoft putting lots of effort, lots of focus. in order to cater for our customers, we had to have addressing space for them, right? So that all has been taken away from Microsoft IT and given to our online services arm. So from that moment, what also helped, and I know this from my colleagues, that in 2012, the World IPv6 launch, that helped everybody tremendously to actually focus the efforts on enabling IPv6 in the network, to enabling Dualstack. So I would really want to say, like, those things, those dates, that when they are kind of agreed in the industry are really important, because they help people to focus on delivering something with a certain date in mind. So I would not underestimate it, even though some people can say, okay, some enable Dualstack and then they switched it off, or some people enable it, left it there, you know, it worked, etc. I would say this is really important because, again, it helped the team to focus all the efforts, right? And that meant that all led to last year, 2016, where all the corporate network locations and everything, all the networks were deployed with IPv6. And every new locations that we are deploying around the globe, it has to have IPv6. I'm a member of a design review team. When I look at this, first thing I go and check on the designs is if IPv6 prefixes are allocated for VLANs, you know, and also then go and check whether they are from the correct region, because we've got multiple /32s that we use in our network. All managed labs are also Dualstack since 2011. In Microsoft, there are different types of labs. So for some, we only provide to the PE connectivity, and some of them we also manage. So for the unmanaged labs and also for so-called secure environments, we don't have them under control, and that is a lot more difficult to move these environments to IPv6. So there is still work remaining, and we'll have to work with the product groups that own those labs on enabling IPv6 there. And as I said, there are still networks which are IPv4 only, which make me feel like I want to take that v4 legacy sticker, and I just want to go and stick it there. I have to leave it to my colleagues in Redmond, because they are more than happy to do that for me. The biggest challenges, so when I looked at this, when I was thinking about it, what actually caused that the rollout wasn't as fast as everybody would like to, really the biggest challenge for Dualstack are people in general. The technology, yes, you know, we needed to wait for it to get there, but it's the people that they need to accept it, that this change needs to happen. You know, there are no more ways how we can hack around it with the various layers of NAT and how we interconnect the network. And also prioritization, because unless it becomes business impacting, then basically this IPv6 problem or thing that we would like to do is always going to get shifted. Also, IPv6 is everywhere in the network, but the network is managed by different teams, or is deployed by different teams. You've got the core network, you've got the user access, you've got the wired and wireless portion of it, you've got the DHCP, DNS infrastructure that supports it, and all the various services. So all these teams have to come together and jointly work. Like Stephanie, I remember your presentation about enabling V6 in LinkedIn, and also before that on WebEx. And you basically solved it by bringing cookies and cakes to the meetings, just to make the engineers to attend the meetings. And I think that's a brilliant idea. You know, I really liked it. Last thing I would like to point out here is that ongoing training is absolutely necessary, because it's a new thing, you know. And even nowadays, it's not a standard thing that graduates, if you hire them on junior engineer positions, that they've got any V6 knowledge. This is a topic that we are discussing in the UK IPv6 Council quite a lot, you know. Not all the universities have these programs in place that actually the young engineers leave the university with current knowledge that is needed by the market. So ongoing training, absolute must. And of course, the thing about vendors and the feature support, that you still have to go and configure IPv6 routing. Why? You know, that there are inconsistencies between different versions of operating systems. And now, I'm now talking from my Cisco experience, iOS, iOS-XE, iOS XR. You've got different lengths of default timers for arrays, etc. You could go on. Frank was talking about it here earlier. So that's stuff that needs to be really, these are all the little nitty-gritty details that need to be taken into account. So moving to IPv6 only, why are we really thinking about it, and why the work has already started? I mentioned that we don't have any v4 public space anymore. We are heavily relying only on the RFC 1918, on the private IPv4. And besides the users, we've got lots of other devices and things that actually connect to our corporate network. And the picture that you can see on the slide behind me, this is not just something as a decoration. These are microherb greenhouses that we've got in our offices, where our catering providers actually use these to supplement the diet of the employees. All these are actually connected and they are monitored on our network. Then we are talking about smart parking signs. Our RNF team, they've got a project in where they want basically to make parking in the Redmond campus much easier because it's so busy. So you will have smart parking signs that will be able to tell you once you approach the campus where you can actually park before you enter the car park. Security cameras, that's kind of a standard thing, building management system, door access systems, printers, we used to call them just printers, now they are Internet of Things, right? So that all consumes IP space. Also, and I'm really grateful for this, and I remember in the council we all were like, yoo-hoo, Apple, finally, they said it, you know, this is what's gonna happen, and push everybody forward with IPv6. They announced it 2 years ago at the development conference, v6 only, apps have to work in that environment behind NAT64. So I went a few weeks ago and just counted how many apps we've got in App Store, because Microsoft kind of doesn't always associate App Store, right? But actually, when you look at the App Store on your iPhone or iPad, we've got more than 87 applications, and that's only what I counted when I looked for Microsoft as the developer of the application. I'm sure there is a lot more. So that's quite a few, which means this decision, this industry pressure impacts us, impacts our business, and if our applications don't work in a v6-only environment, that means we will be kicked out of the App Store. There are also requirements by the US federal government for cloud providers, and I will talk about it a bit later. So actually, this industry pressure has direct business impact on our product groups, which I think is great, you know. That just helps the cause. And I would say this is true for anybody here in this room. If your business has app on App Store, how do they test it, you know? Because Apple, as Stefan mentioned yesterday in his presentation, T-Mobile, Apple doesn't tell you where your application has failed because they don't test every single button in your application. So that happened to some of our product groups, that they were rejected. And then they came to IT and say, oh, we need a network where we can test it because we don't know what happened, right? There you go. So I also mentioned the v4 address space exhaustion. Overlapping space between the Azure, us, MSIT, the corporate network, between the acquisitions, like with LinkedIn, everybody was hoping that we will be connecting only on IPv6, but unfortunately that's not the reality, because those applications that are managed by IT, not all of them are even IPv6 ready, right? So that like daily applications that have to support payroll, you know, HR, the management, people management, etc., that's not on IPv6, so these things also put pressure on the v4 addressing space and various translations in the network. Operational complexity. Our marketing communication people didn't allow me to put here a picture, but I would like everybody to imagine Hello IT. Have you tried turning it off and on again, right? So this is still truth, because, for example, we come across this troubleshooting procedure where basically first thing is for the engineer to check whether the user is on Dualstack. And if they are, tell them to switch off IPv6, right? That's wrong, okay? And we don't want that to happen, so that's one thing. Then recently we've come across, there was actually an answer of the support to a user who was complaining that he couldn't access couldn't access Office 365, basically, on Dualstack network. And then we actually went with our engineers and looked. There was the IPv4 policy on our firewalls, edge firewalls, wasn't the same as for IPv6, or the other way around. V6 wasn't the same as for v4. So now we are actually working very intensively with our security team in order to make the policies the same, you know, across all the edge firewalls. But those are the little details. However, that's something that makes the operations, you know, hard. So we hope with moving to single stack, these problems will go away. And I must say that one thing that our management has taken on. They said, okay, this is our strategic goal. We really want to prioritize this and focus on this, which is great. You know, the support of management is the most crucial thing one can have. As we engineers, we like the technology, we would like things to progress, but our wishes don't always align with the business goals and strategic goals that our managers has. So this is really important. And I would also like to say that Dualstack is really just IPv6 half done, right? So this is where we kind of are. It's a crutch that everybody is using in order to get the v6 experience, but we want to move beyond that because two protocols are just difficult. So current status, where are we? In Redmond, we've got two test networks, IPv6-only networks. One is for the wireless guest, and one is for wireless, wired and wireless corporate. And this is really a very simple setup. We are leveraging local NAT64, DNS64. NAT64 is running on A10 platforms, and DNS64 runs on F5. Now, then here comes the reality, right? Where we hit the DHCP, non-support in Androids, and for example, we have to test all the address acquisition teams in our POC because basically when we allow Android clients in the network, we have to cater for them as well. So Windows and Mac support both DHCP-v6 and Slack, Android just Slack, right? So this is something that we have to take into consideration how we are going to approach it. So for example, on the guest network, we have to support all the devices because we don't have any control over it whatsoever. This is going to be a question that we have to ask when we will start planning our corporate network as IPv6 only network. What are we going to do there, right? So for the guest network, the choice is DHCP-v6 stateless and RDNSS. There's a blog that my colleague Marcus Keen has written, and it's created quite a little bit of noise. It created quite a little bit of noise when it was published in January this year, where basically he's talking about the issues we've got with feature support in the wireless LAN controllers, because we use two different vendors in the network to deliver wireless to our users. And in one case, we are waiting. Actually, this is now being tested. The code is being tested. There was a bug with the dynamic access lists that we need to have support for them in the guest network. And the other vendor basically doesn't do DNS snooping for v6. So we are waiting for that feature to be also available. We should have the code for testing probably end of May or end of June this year. And we hope to start rolling it out later in summer. And also our own issues. This is something that also stirred the community quite a bit. I'm sure you have seen the emails on various mailers that by anniversary update in August 2016, we have broken DHCP-v6. Neither stateless nor stateful worked. And the only workaround was to basically manually release, to ask for a new release. So that, I'm very pleased to say that that has been fixed in the Creator update that was published only a few weeks ago. And actually, the Creator update also brought RDNSS support in Windows 10, you know. But I would say we have to thank a customer here, really, you know, because Marcus, my colleague from the network architecture team, worked very closely with John from Comcast. And this is a real example of very vocal customer. And when I was in Cisco, I would say the same to my customers. You have to say it if you want something. If you don't say it, the vendor say, nobody wants it. And if you tell them, well, it's going to stop some business for you, and if the business is significant enough, that's going to really ring the bell with people who prioritize features for the various operating OS releases, right? So John helped, together with the MSIT, actually getting the feature support in Windows. So finally now you don't have to, you are not kind of limited with Windows 10. So besides having two test networks, which you can say, okay, that's deployed in our IT buildings, and we are kind of trying, there are a couple of users, people who try stuff now and then. We also, what are we doing in order to help our product groups that are impacted by the Apple mandate and also the FedRAMP mandate for cloud providers? We have to actually roll out for them custom networks. So Skype product group are very busy working on V6 support, and that's not just Dualstack, but IPv6-only support for Skype for Consumer, Skype for Business, or previously Link, and also for Microsoft Teams, because that has a voice component. That all has to work in IPv6-only environment. So we are really tactically, at this point in time, we are rolling out for them V6-only networks in the couple of locations where they are based. However, this is a security exception. Our security team doesn't want to have separate networks besides guest and corporate network, because then there are certain considerations, security considerations that need to be applied and quite a lot of requirements we have to meet. And also, this can't scale. Imagine how many product groups we've got, and if we rolled out separate IPv6-only networks for these folks, that's just unsupportable. Our operations would refuse to support it. So we know this is a tactical kind of stopgap approach, and we just had to do it in order to make sure that the business continues, right? So some people can ask why wireless guest first, because Cisco, they have decided to take a different approach and turn their corporate network on to IPv6 only. So from our perspective, we really want to test what IPv6 only looks like. We want to test what is going to break, and we can tell you quite a lot of things break. So we are already learning even in the test phases, in the pilot phases. Then of course, the application profile is much easier. So it's guests usually want to have access to their email, to the internet, to some IM applications. But I want to say here, there is a little bit of difference here in Microsoft than what I've seen in other companies, including Cisco. Employees can actually connect to the guest network as well by entering our AD credentials. Because if I want my smartphone, which I don't have here, if I want my smartphone, which is not company provided, if I wanted to connect to the corporate wireless, I would have to enroll it in our Intune portal. And so then IT would manage my device. I don't want that, because I bought the device. So I want to connect to the internet. That's all I need really, so that my Outlook can download the emails and I can access my calendar. So I can actually connect to the guest network. So it's also our internal employees that can leverage this network. But what they will use it for, they will actually go to the internet and consume services that are in the cloud. Because anyway, in Microsoft, the trend is moving. We are moving lots of our internal applications. We are moving all these services to Azure, right? So this is also interesting, but basically we are not impacting here the corporate applications that are accessible only on the corporate network. This can be also used by the internal development. So as I just explained, our developers, the employees, they can go connect to the network and then go and test their applications, right? So they will have something that is scalable. It will be universal in every location. So it will be easier to support for our network operations. And also, this is a bit of an interesting statement, because the SLAs are a little bit relaxed, but I can assure you, when we had a discussion about wireless guest 2 months ago with our management, there was a very heated discussion about the code quality and when this is going to be ready from the vendor perspective, and when we are going to be ready to roll out. So it's not like that nobody cares. They do care. It's a user experience. If you've got somebody visiting, you don't want them to say, oh, Microsoft wireless guest just sucks, right? You don't want that. So even though this is a little bit relaxed, it still gets a lot of attention. So we have to proceed step by step. As I said, we want to get exposure and move faster. The problems that we have hit, obviously, is the differences between various user and devices, operating systems, and how they support address acquisition, right? So DNS name resolution, Windows, I apologize, this is the statement is a few weeks old, so until beginning of April, Windows 10 supported only IPv6, right? So since the creator update, we support also RDNSS, which is good, but we still have the thing with Android. So in the end, you end up with a matrix of the clients and what they support and how actually the functionality that they need, how actually can be delivered to them. So then we need to support both in the network, right? That means a parallel IPv6 infrastructure, stateful and stateless, plus RDNSS on the first hop routers. The problem is that not all our building CPEs support RDNSS. So we've got a mixture of ISR 3900s, ASR 1000s, Catalyst 6500s, we've got a mixture ASR 9000s. Here again, I would like to say that thanks to big work that my team did with Cisco on the iOS XR, the RDNSS support is there in the code since 6.1.2, which is good. So we are actually in the process of testing, certifying this code, and hopefully this is also going to help other people who are using 9Ks as their first hop routers. Then the solution at the time, so in the solution, because not, as I said, the 9K didn't have the RDNSS support, was basically to have a layer 2 VPN to a centralized default gateway within a campus, because it's a within like confined space, so there are no big distances. This is something that we can actually afford to run it on a certain router pair. But this is not something that's gonna scale everywhere. So what we are going to do in the future is basically deploy this functionality in the regions as we basically grow the IPv6 only deployment. Issues that remain, so for example, until we have the code certified, which is a many months effort with the vendor, and then our own internal testing, means that basically not all locations we can go and just deploy EVPN, simply because either the routers don't support it, or in the tail sites on layer 3, we've got layer 3 VPN from a carrier, but we can just go with extra cost for deploying layer 2 VPNs. Some routers will never support RDNSS because they are simply too old, for that. So they will be subject to platform refresh. You can see that, or the other solution would be pseudo wires, but because we use a pair of building routers in each building, then you got the issue with redundancy, how to deal with that. But what's going to happen, basically, again, that's a normal thing that every IT organization thinks about it. Let's roll this as we go through our lifecycle management, when we are doing the platform refreshes. But again, something that we have to take into account, what are these features that we need in building CPs when we talk to our vendor, when we are looking at a new platform. Because again, if a certain flavor of operating system has it, it doesn't mean that next hardware with the same name of an operating system has the same features, because that's not always the case. Which is tough for the vendors, because I know this all, right? I've been 10 years with them. So this is just, for your reference, a little table that I put together after having a conversation with one of our product groups. What does it actually mean to test IPv6? So you've got the Dualstack. It's very small, so you will have the slides for your reference. But you've got the environment where is Dualstack. Then there is a NAT64, which is like, why am I putting it here? Well, you will need to think about it that you've got the v6 only client. On the LAN side is v6, but then there is the NAT64, the NAT64 devices, and then you've got a v4 network, right? And the resources that they're accessed are on IPv4. So, and then you've got the v6 only, where the whole path from the client to the resource is IPv6. And the network in between can be dual stack, but the resource sits on IPv6 only. So then you have to think about the end user devices, the operating system, and what is supported and not. And I must say that all these, we're not going to see it, but let me use a mouse here. So everything, I could have like copy pasted it here, or maybe organized the slide a little bit better. But this all really applies to the different operating systems. So if in your organization you are not running Windows 10 with the Creator update, make sure your IT organization pushes that update as soon as possible, because that will fix the DHCP-v6 bug. Okay? So that's just one thing you need to bear in mind. What are the wins and challenges for our IPv6 only efforts? I would say the wins are that thanks to the industry, there is quite a big awareness, and it actually impacts our business. which is good for us because it helps us, it gives us a stronger voice when we say this is something that we need to do. It's not just the engineer's dream, but this is a reality that impacts our business. And of course, because we have already been through the Dualstack deployment and people understand that it's operationally challenging and it's complex, that we basically want to go to v6 only because there will be benefits on this side as well. Again, the same thing are people. And it's now more not about them saying, yes, this is a good thing and something that we need to do, but it's, again, prioritization and alignment with other teams. The good thing is because our customers, product groups, need this from us, this helps us to prioritize. And the same thing is our own bugs and things that we don't have in our operating system, in our Windows platforms, and also, of course, the vendor features. Like, how are you going to manage these network devices on IPv6 only? So this is something that I'm going to discuss, so because tomorrow I go to Redmond and I'm there for the next 10 days. And I am going to talk with our engineers, like what are the features, what do we need in our network devices, wireless, wired, from the management perspective. And then we need to go to the vendors and tell them this is not there and we need the support, otherwise we will not be able to move forward, right? So, but that's kind of like a part of the rhythm and something that once you get into it, it will become natural, right? It will be immediate thought, not an afterthought. And this is a funny one because there's a conversation I had about 6 weeks ago with a different part of Microsoft. And basically, they kind of were wondering what this IPv6 is. It's like, okay, so, and why should they care about it? So this is still a little bit of a problem, but we just need to push on, right? So the future directions, we are going to deploy more of the NAT6 DNS6 instances in the region. So I know like in the upcoming weeks, we are going to deploy this in London and in Dublin for the European region. We are going to move the wireless guest from pilot that is running inside IT building to more pilot sites, and eventually, hopefully within a couple of months, we will start rolling it out within regions. But this will, again, depend on the vendors because we've got the different vendors in different regions. So again, you know, where are the bugs and where are the missing features? But this is the plan, really. Also, what I am discussing with the team is planning for IPv6 only corporate. But I'm really aware, as you've seen, 1,900 applications that IT supports. This is going to be really a very, very slow and very tedious process. However, we should not turn away from an opportunity just because it looks like work, right? That's the famous quote. So basically, that's what we need to do. We are also working on internet-first strategy. That's for certain smaller branches that don't need corporate connectivity as much as some larger branches. And basically for that, we also need to consider, and I know that my colleagues are working on this, so v6 only for the internet-first strategy. And of course, v6 only management of the network devices. That's something that we'll need to do an audit of the features, what's there not, and work with the vendors. And of course, right, while we are working on this and enabling the guest and hopefully the corporate network and management of network devices, we also have to work with our internal customers on them enabling v6 only in their products and their v6 only strategy. So now think about it. Everything Windows, right? IPv6 only. Wouldn't that be interesting? So this is something that I would like to call the Microsoft effect. When I looked at the market information and so on, about 80 to 85% of global laptop desktops, now it's actually also some tablets because Surface is becoming quite popular, that actually runs Microsoft Windows, right? Then also hundreds of millions of devices. You're not talking just about what you have here on the desk in front of you, but you're talking Xbox, which is a very popular gaming console, HoloLens, Windows servers, those hundreds of millions of the instances that run in data centers. So now I'm going to say it like, how long is it going to take till we turn v4 off in these products? And this is an idea that we are starting to socialize internally in Microsoft. I'm not saying this is something that's going to happen this year, in 2-3 years, but it is the ultimate goal we are going to work towards with our product groups. So I can help you. I hope this can help you in the argument and can help all the enterprises that they need to start seriously with IPv6. Like, there is no more excuse. So this also leads me to a question: how will you support your own customers with IPv6 only, right? How? So think about it, because this is coming. And people who know me in this room, they just know that I'm quite serious about this stuff, and I am not worried to say things, that I think. So now more the UK IPv6 Council. So this is we started in 2014. Is it 3 years already? Yeah. And basically, I can blame it on Ladit from IPv6 Forum, and also one excellent professor from the University College of London, Peter, who is very old but extremely energetic for his 80s. And they basically cornered me at the V6 World Congress in Paris in 2014 and say, like, UK is not doing anything with IPv6, nothing's happening there. But we heard that you are talking about this a lot, so you probably should start a task force. And I was like, oh my God, But in fairness, for already many years before that, I was talking with different customers, organizing IPv6 workshops, because I knew that this was coming and people needed to be aware. And usually why we refuse change is because we are afraid we don't understand something. Once we learn, then we get more comfortable and actually things can progress. So UK, I'm really happy, is about 25% of user traffic on IPv6 at the moment, which is a great achievement thanks to Sky. Yesterday they were also on one of the statistics. They're second largest ISP in the UK with about 6 million subscribers. So thanks to these guys that I work with in the UK IPv6 Council, I would like to share a couple of observations. So service provider in IPv6. For you guys who haven't started or are just thinking about this, the business case can evolve in a very different way, more different way than you expect, because one example in the UK was that first they were actually thinking about CGN, carrier grade NAT, and basically how they are going to deal with IPv4 depletion. They knew that there was this IPv6 thing, but they didn't feel ready for that at all. At the same time, they were coming to a platform refresh for the edge routers, and they knew that they needed to specify features and functionalities and scale for this next generation PE at the time. So everything really evolved over the time. While they were working on the business case for CGN, they were doing some testing, and at the same time say, okay, let's try with V6. And basically, just by bringing it to labs, give it a connectivity, enabling a VPN in the network to the peering routers and out on the internet, basically they started to get some experience. And then the big breakthrough was, and I know that David's going to talk about CGN as the business case for IPv6, is they came to the conclusion that it was too difficult operationally and it was also costly. I know that Cisco published a white paper together with IDC, I think it was, about the cost of deploying CGN in wired network and also then for mobile. So this actually is a classic example and a real-life example where this was just too complicated because they would have to do lots of reporting from CGN, which is quite demanding on the supporting infrastructure. And they knew that V6 needed to happen. The benefits wouldn't be immediately obvious, but this is something about future-proofing the network, right? And services for their users. Also, they had got CTO of that organization who was very forward-thinking and thought, like, as soon as it becomes business as usual, so nothing exceptional, nothing too difficult, something that just is part of what we do every day, then let's go out and roll it out. Timing helped them as well. This is important, so nowadays there is no more excuse that we can do with V4. RIRs don't have any V4, so basically now we are in a better situation than 5-6 years ago. So as I said, they tested it and eventually actually deployed it. They avoided completely the CGN deployment. But now they are aware this is Dualstack, so that doesn't address the V4 address depletion. But in the UK, the market is quite saturated, so they are not growing as rapidly as basically they would need to consume V4. But when I had a discussion with the guys, they said, well, we know in 3-4 years we will have to look at the V6-only network and transitioning to MAP solution, possibly MAP-T rather than MAP-E. But that's just a matter of really technology preference. From V6 readiness perspective, this is quite a lot of work, as every ISP was going through this or is preparing for this, you can imagine, right? So this is not just hardware, software, this is access lists, how you manage devices, everything has to work with IPv4 and IPv6. So the readiness term is quite wide, but you need to go and define it, right? That's true for everybody. Then as a CPE, and this is a kind of a different situation in Europe, as I know, when compared to North American market, in Europe the ISPs provide residential router to the subscribers. So they actually manage the router, which from V6 deployment makes it a little bit easier because they've got certain control. They can go and upgrade the code on the devices once they've ironed out all the issues with the suppliers. So also important thing is that once you start introducing new CPs, you need to remember that the V6 is there, the testing restarts, but over time it gets easier. So there are lots of things that actually this was, and singularly I know it from British Telecom, I know it from Sky, I know it from the other ISPs in the UK, that basically this is the most difficult part for them, the CPEs, because they've got so many flavors of them in the network. Unless the customer refreshes the contract, basically the thing just lives covered in dust under a table somewhere in the house, and you don't have 100% control over it, but they've got better control over it because they provide a CPE. I already mentioned, for V6 to be successful, and this is something that people are still coming to terms with this, is that it has to be business as usual. It has to be a normal thing. And basically, they needed to go and develop a model for what a CPE is going to look like and what are the features. And they, based on this model and what they tested, they went to the suppliers and they say, this is what we need your CPEs to actually support in the firmware. OSS, BSS, parental control, filtering, all the other types of services that support your network and services for your customers, that's something that has to also be V6 capable and really work, not just have a sticker that says, yes, I support V6, but actually really work. Operations, again, I know that first the guys, they went through like months of training where every team went through a week-long training, and eventually this all became a part of standard training, and they've got a like new hire training, and there it's a part of it, and it has to be normal thing. I also heard from somebody, they told me basically how they go about it with the new hire. They tell them, oh, this is just something that we do, you know. Everybody does it here, even though it's not true. They just basically create that mindset. I was like, yeah, you just have to work with IPv6 and just understand it. Stefan mentioned it as well, and the same thing goes for any ISP. Make sure that your subscribers are happy. Communicate with them, monitor social media. I know that the guys in the UK, they've done lots of work on managing the community, you know, just by lots of people think that they are experts when they actually are not. It's a natural thing, you know, you've got an opinion. That doesn't mean that you've got an expertise. So you guys are the real experts. You need to go and manage this with the users. In the UK, as I said, we were getting lots of stick that the V6 wasn't taken off, but at the same time, the advantage was that the ISPs were latecomers, so there were other large ISPs that ironed out lots of the problems and issues. So being late is not always a bad thing. So you already have some things that are already working there, just take advantage of it. And the reality is that the enterprise side, because that's not the one that brings business in the house, stays on IPv4 for a certain time, right? Because the telco guys don't have full control over it. They don't have control over it. They look after the telco network. But then I know that, for example, if the ISPs got large data centers, they're again with virtualization and containers, they are hitting the issue of V4 runout, right? So that's where we will see a change. Enterprises and V6, why it's not happening. So we've got the large guys like Facebook, Apple, let's say Microsoft internally, where we suffer with the V4 runout, right? Even the private space. But the reality is that most of our enterprises, small, medium businesses, don't suffer with the same problem because they are not technology-focused companies. IT is there only to support what they do. So basically, for them, technology always equals cost. So if we as technology companies have it hard, they've got it even harder than us. That's a reality, right? And it's hard for them to tie the revenue protection to IPv6 rollout. They don't suffer with this. They have lived in the IPv4 bubble proxied to the internet for their entire lives, and they are quite happy with it, because why should they change? They are safe, right, from the bad, nasty internet, as John was talking about it yesterday. And then also we need to realize that not every enterprise sells to consumers. There are a lot of enterprises that sell to businesses. It's business to business. And on that level, basically, there are intranets, these kind of secret networks that nobody's talking about, where you've got the automotive industry, where you've got finance industry, where you've got airlines, whatever you're manufacturing, like oil operations, etc. All these companies, they have got these intranets that they use for communicating with each other, doing business with each other. Sits behind many layers of NAT, but they are used to it, and they don't need to change, right? They also have like two different DMZs. One is serves the consumers, one is actually for the private network. And until we get to a point that in countries which don't have enough IP address space, where the regulators start asking these these organizations and start asking them, so what are your IPv6 plans? They will not change. The example is actually in India and in financial industry, where India, the regulators are asking the banks, you know, what are your V6 plans? Because the country doesn't have enough IP. Why, yes. The good thing is that V6, no matter if they want or not, V6 is everywhere in all the devices that connect to the network, and you can't switch it off. So basically, the only way how to protect for the enterprise, how to protect from IPv6 threats, is to deploy it, right? So that's one driver. The second driver, I hope, is going to be the Microsoft effect. That's going to help everybody as well. As I mentioned, V6 only in Windows. First, they also focus on, again, what is their business, what brings money home, and that's the consumers coming over IPv6. So the typical approach, as it was for many guys in this room as well, start SLB 6.4 on the edge for the public services, and that way enable V6 for the consumers. Mergers, acquisitions, and when the companies divest as well. That also has puts pressure on the IPv4, and therefore V6 needs to be taken into account. I'm sure people here have heard of segment routing V6, so lots of innovations that are happening in the IETF and other standard bodies are really focused on IPv6, and IPv4 is an afterthought. So if you want to progress your network in the future for delivering new services, V6 is again inevitable. And as I said, in the last 2-3 months, I spoke with different companies where basically they say, in data centers, this is our pain point. We don't have enough v4 for the containers and virtualized environment. And basically, we don't want to do dual stack because that really doesn't address the problem, as Frank was talking about it here extensively as well. So v6 only. The good news is we are, again, many years on, you know, from when these thoughts started, and V6 only is actually more real than it was a few years ago. So these are really my observations from the council, what I've seen in the market over the years, and that concludes my presentation.
Hi, you mentioned about some bug in DHCP v6 for Windows 10. What is that bug?
So that was introduced in the anniversary update in August 2016, and basically meant that neither v6 stateful or stateless worked. You basically, the device had to be manually, you had to release and request again to receive an address from the DHCP.
Cody Christman, Wipro. I was curious, I kind of like it, but you're using A10 for NAT 6.4 and F5 for DNS 6.4. Any reason for that?
F5, they were already our standard load balancers. And then I think when my colleagues did the testing, some vendors didn't show any interest in a NAT 6.4 platform. They didn't kind of come forward too well. A10 did the best in the testing. F5, there were some things missing there. Some stuff wasn't top notch. So basically, in the bake-off between the various platforms and vendors, it was A10 that won.
I don't know if it's fair that I ask a question, but I'll ask it anyway. So on probably the biggest push of adoption for Azure for IPv6 support, right, was the fact that MSIT needs to move their infrastructure from what they're doing today into Azure because that's a corporate requirement, or at least I believe it is.
Yeah, that's something that's a work in progress, yes.
Right. So can you talk about the journey of what, have you had to interface with the Azure team about what's going on there? And then talking about v6 only in Azure versus Dualstack within Azure, because obviously it's Dualstack today. It needs to move to v6 only for support.
I'm gonna take your mic and I'm gonna pass the mic to Todd, who is best qualified to talk about this because he's from our team and then he spent a few years with Azure and now he's back with us.
So obviously we're the IT guys, so we really don't represent Microsoft products and services. But Azure is certainly aware of v6 and the need to move there. You know, they've already started on north-south traffic, east-west is next. Certainly we're a driver as an IT organization. We're telling them we want to move all of our line of business apps there, but guess what? We're working towards v6 only, so we need your guys' support. So we're continuing to press them along with other companies and other users of Azure. So it's coming. I don't know what more you would like to hear. Yeah, it's certainly a P0 for those guys. It's a challenge. You know, they were working on quick to market, which means you have to make some compromises, and v6 was one of the compromises.
This is John Lee with Internet Associates. Since you're doing Azure's, can you discuss the number of IPv6 addresses you're going to be using, say, in your global enterprise, and how you're going to be managing those?
You want to take this? Or?
No, you take it.
So back in 2006, we got a 32 from Aaron, a 31 from Ripe, and a 32 from AP Nick, I think.
Yeah.
And we're on our third rendition of addressing plan. We're doing it regionally. We want to obviously make sure that we can do aggregation as much as we can. So when we do face the internet, we can give them the /32 blocks, things like that. It has caused some problems when we think about how we do symmetry for stateful firewalls. How do we advertise? So I hope nobody throws anything at me, but we're doing NAT 6.6 to solve that problem. We hate it. Yeah, go ahead. I'll take it. We would like to solve it, but it was a funding issue that we knew we could solve with money, but as an IT shop, we're always, you know, scraping the bottom of the barrel. Even as a large organization, we still are. We're a cost center. But our plan has always been to sites are 48s, networks are 64s. We do aggregate by, so as Veronika talked about, we use carrier MPLS as a transport. We use a /40 per carrier to support all of the sites in there. That seems to be working pretty good. So far, that's kind of our model. Large campuses, obviously, we continue to leverage, you know, /40s or something in those ranges. Does that kind of help?
Yes. So how many different ASNs are you working with in terms of your address space there? It sounds like you've got a few of those also.
So you want me to keep going?
Sure. I don't remember all the essence yet.
Internet facing, we try and leverage Azure's 8075 as much as we can, because as an IT shop, we give them our traffic. For us, it's free. Yeah. Woo. But internally, we're at 2 ASs across our corporate backbone and sites. Each data center is another AS. So, but we only have 4 of those, so it's not a lot. And then we also have, as an IT organization, a single AS that we interface out to the rest of the internet, 3598. So we're trying to limit the number of ASs as we possibly can, so that it simplifies our life. And 4-byte or 2-byte ASs are hard to come by now.
Okay. Thanks, Todd.
Thank you.
Very good. I think everybody's ready for coffee. Well,
All right,
thank you guys for your attention.